if you start moving the signal generator frequency away from where you have the receiver tuned, okay, you move it 6 kc, and your signal should be down, drop 6 dB, or like 1 S unit. Do you see what I'm saying? And then if you went like 10 kilohertz away, it may drop like 60 dB, which is like almost disappearing. Do you follow me? It maps out the slope.
Oh yeah, I follow you now. Understood. I got you. Makes sense now. Okay, that's cool. Yeah, I was just always wondered that with the NC3 or 3.
So you can measure that with a signal generator. Now, see, what they really good crystal filters. I'm talking about vintage radios now. They have what's called real good shape factor. In other words, there'll be, say, a 6 kilohertz filter that's multi-pole that has a good shape factor. It'll be 6 kc wide, but then when you get out to 8 or 10, it drops off really, really sharp. You see, that's what you want. You want the good fidelity, but you don't want it at the expense of being real wide on the other end, because everything it slopes down. The only time you're going to see brick wall filters is with an SDR. In other words, if it's a 6 kilohertz and then you go 6.1 and there's nothing there, you can't do that with regular filters. It's impossible. Okay, to have it that sharp. So there's always a slope. So it's very important to know that slope. In other words, how many dB per kilohertz? Because without the dB qualification, really the number of the selectivity is meaningless.
I got you. That makes sense. They did a test. I can send you I found a test on the 303 that has those specifications with the, at 6 kilohertz, how many dB down it is, and so on and so forth. I'll have to find it again and send it to you. It's got a bunch. I don't know if it has the 140 on there. It has a couple Hammerlin receivers on there as well. But yeah, it always seemed, the 303 always seemed kind of a bit on the wide side. But it sounds great, I always enjoy it, but when it gets, real crowded on here at night, I see what you've always said about, the trade-off that you get. If you want really high fidelity with these old Bollinger receivers, you're gonna compromise with QRM or QRN and heterodynes and so on and so forth. So it definitely is a compromise, but that's I guess that's why we have these new rigs now as well, so you can combat that. But like with your 160, you can notch out heterodynes with that pretty good, can't you?
Well, you can narrow it up. Same with the 140 with the crystal selectivity. I mean, and the crystal phasing, you can mess with it okay. But all that stuff naturally affects the received frequency response. But, you want to have a receiver that you've got some tools in the toolbox to deal with QRM. You just have one big wideband receiver, and it's only good up until about 5:30 at night. Then after that, you may as well forget it.
Right. No, understood. Trying to find this test that I was talking about. Here it is. I found it. Let me see. C303. Yeah, okay. AM audio frequency response. At 5 kilohertz, it's minus 15 dB at 5 kilohertz, minus 22 at 6 kilohertz. It didn't test it any wider than that. Minus 10 dB at 4, minus 5 dB at 3, minus 2 dB at 2. So I guess where it starts really dropping off is kind of where the filter is starting to close out, correct?
Well, yeah, everything is a slope. Because, you know, as you tune across somebody, their signal starts to go down gradually as you tune it away. They don't just, like, disappear, like where I'm on 3873. Well, you turn your radio to 74, and I'm still there a little bit, but my signals drop down. That's the slope. That doesn't, like when you tune to 74, I don't disappear. So that's the slope. You know, kind of analogy is, you know how they rate horsepower for engines at so many RPMs? Well, if they just gave horsepower and no RPM, that's meaningless. Because what's that like? Does it have low-end torque? Is all the horsepower at 8,000 RPM? If they don't list the RPM with it, it really doesn't tell you anything.
Right, I got you. Makes perfect sense. Okay. Yeah, I just sent you a couple links there. But no, I mean, it's like you said, it's good to have a couple tools in your toolbox. And that 303's got a lot of tools in its toolbox. It's got, you know, variable audio, different tone. You can adjust the tone, the highs, low, regular, mids, all mids, you know. You can really narrow it up. It's got like your full wide, your wide filter, then another narrow AM filter. Then it's got two different sideband filters. It's got a CW filter. And I really love that receiver, though. That 303 is like a Cadillac, man. And that big, heavy tuning dial on there. So baby, it's like, it's like weighted when you turn it. And a big slide rule dial. I should get in there and put that dial cord in there for the frequency drum, but that's a real pain to do. It's just one of those things. It works so good, and I don't ever take it off at 75 meters, so why mess with it, you know? W3MMR.
W2SDR. Well, it's important when you see, as you saw on that thing, the link you sent me, it's always a 6 dB down point is very important, because 6 dB is really starts to roll off. So that, because if they don't give you that, you don't know what it means. They always have to qualify it by dB. It's same with the frequency response on a stereo. You know, when they say 20 to 20,000, well, to 20, a lot of times it could be 10 dB down at 20 hertz, which means you can hardly hear 20 hertz. So that's why they have to qualify it with a decibel reading, a spec. The 140's doing okay here. I can slightly hear a heterodyne, which is okay, because if it's an 8 kilohertz bandwidth, if 8 kilohertz is 6 dB down, somebody 5 kc away from me, you're going to hear it. You're going to hear that 5 kilohertz tone of the heterodyne of the 5 kc, because 5 kc is within the 8 kc bandwidth.
Yeah, okay, yeah, it says down here, notes, maximum IF bandwidth is about 8 kilohertz at 6 dB. 6 dB down, so. Yeah, whoever did the tests on here, W1VD, did a good job with the tests. I don't know if you checked out the other receivers that he tested there, like the 183D, the Hammerlin HQ 120, the 170, a whole bunch of receivers. So I thought the 140 was on there, but I guess it's not. Apparently I was wrong.
Well, you can, I misspoke. The 8 kilohertz at 6 dB down, that's 4 kilohertz audio bandwidth. Okay? So at 4 kc, it's 6 dB down. Well, that means at 5 kc, it's probably going to be about 8 dB down or something, which 8 dB down is still audible. You see, so somebody 5 kilohertz away will still be audible on an 8 kilohertz filter. Okay? But that's the beauty of an SDR, because they're brick wall filters. When it says 8 kilohertz on there, when you get to the 4 kilohertz point on either side, it drops like a stone. You can see that on the pan adapter.
Yeah, hold on. if you can hear that horn going in the background. Too many car alarms going off out front. I'm going to shut my window. I got you now. Yeah. Well, yeah, that's what I took that as, 8 kilohertz, plus or minus 4. So, I knew what you meant. So, okay, yeah, that makes sense. So, like you said, at 8 dB down, you would definitely still be able to hear that. But no, like with these, like you said, with these SDRs, man, once you get to the, your receive filter, you can see on the pan adapter. Once you get a little bit louder than that, I mean, once you get to the edge of that filter, it drops off like a, drops like a rock, which is great. And it's the same thing with the transmit bandwidth. And obviously, as you can see, on AM and especially on sideband with these rigs,
Oh, yeah, well, you would have killed for those filters back in the day. Well, first of all, it was impossible. And in vintage filters, you have a number of poles in a filter, which is sections. The more poles, the better the shape factor is going to be. So in other words, when you get out to the 6 dB point, after that, the more poles you have, the sharper it just drops off. Drops way off after that, rather than gradually. Now, a receiver like a 140 has no crystals in it. They don't have filters. The bandwidth is determined by the LC networks, which is the IF cans. The amount of inductance and capacitance in each can, determines the bandwidth. So there is no crystal filters with different bandwidths. So how it's aligned and how those IF cans are manufactured gives you the bandwidth, and there's really not too much you can do about it. In a receiver like this, say you sweep a line, you can adjust somewhat the shape of that filter. And that's what Brett was saying. He reminded me, I forgot all about that you can see that on an SDR. Because an SDR is basically a spectrum analyzer. And see how receivers work. We could talk about this more on the air, but how the receiver works like these old ones is they take the frequency that you're receiving and they convert it down to the IF frequency, which is 455 in most of these old receivers. So they make every signal that you receive, no matter what frequency it's on, what meter band, they convert it down to 455. So the main receiver is a 455 kilohertz receiver. That's all it is, a one frequency receiver. And they convert all the frequencies in the front end down to 455.
I got you. I was thinking, when he was talking about, I thought he was talking about 455 megahertz, but it's 455 kilohertz, right?
Yes, 455 kilohertz, and they just picked that arbitrarily. Some radios are 262, but most of them are 455 because it's below the broadcast band. So it's out of the spectrum that you're actually can tune to that frequency with your receiver. So that's how they make the receivers very simple to do, because they don't have to realign it everywhere you go in different frequencies. They just have to convert it down to 455, and the whole receiver is basically aligned to the one frequency to make it real good at 455. Now, a dual conversion receiver gives you better selectivity. In other words, there's dual conversion, which in other words, it converts the frequency that you're receiving twice. Most of the time to 10.7 megahertz first, and then 455 second. Now you're saying, well, how does it work at 10.7 megahertz if I'm listening on 80 meters? Well, that's because every frequency that you're tuned to below 10.7 where your receiver only is single conversion, because it's below the second frequency, so it's all just 455. I got you. Okay, I understand now. I was just reading about that because I was wondering what single conversion and dual conversion was, and what the difference between the two, because like the HQ129 I think is a single conversion receiver, and I think the 170 or the 180 is a dual conversion, and I was just curious to know what the difference was, and now I remember reading that.
when you said that. So okay. Now, how would you see the filter on the on the pan adapter, say, from the the Harlan? How would you get that? Be able to see if it's aligned?
Well, what you would do, if you look at your 140X manual, this is W2SDR, by the way, there's a page in there that shows the filter bandwidths and the filter slopes.
Okay.
Well, so you have what's symmetry, so they look like a V, okay? So what you do is you pick off just after the third IF, which is the end of the 455 IF amplifiers, right as it goes into the detector. So you hook a probe right there, and then you run that probe into the receiver jack on your Anon. So in other words, your Anon is going to receive 455 kilohertz that your receiver is outputting. You see what I'm saying? And you could align those IF transformers to give you the maximum amplitude, which is the maximum gain, and the proper symmetry in that V shape that you see. In other words, you don't want it tilted one way, tilted the other way. If it's tilted, what you're going to do when your receiver, when you tune something that's mistuned like that, you'll hear that it'll be like to tune the guy in won't be at the same spot that the S meter peaks at. Do you follow me? You've probably seen that on some receivers that are not aligned properly. You've probably even seen that on CB radios.
I have. I'm looking at the procedure now. Looking at the alignment procedure now. Just pulled up the manual. Okay, so you'll see I gotcha. Alright, well, that makes perfect sense now. I thought I knew you had to probably pick off somewhere and put it into the antenna jack of the Anon. I'd be interested to try that. Well, I'd like you to, me and you could do it. I want to have you here for the first time, you know what I mean, to do it. That'd be cool, though. W3MMR.
Oh, it's cool, all right. And because I'm using the Anon essentially as a turn this power down a little bit, it's getting hot. As a spectrum analyzer. You notice when you hear me talking, like if you're looking at your Anon now, you see my frequency response on either side of the center like that. Now it's going up and down because I'm speaking. It's not like a sine wave or a dead carrier. Okay, but if you saw what the carrier looks like, you would see it sloping. You can see basically what my bandwidth is by looking at my signal on your pan adapter.
Actually, looking at noise response.
By looking at the carrier?
Yeah, on the scene, I think Brett's in there. What I do to make it much easier to see is use what's called a noise generator. Now, I know what Brett knows what one of those are. It puts in random noise into your receiver antenna jack, okay? And then it's really evident on the SDR or a spectrum analyzer when you hook it up to the IF.
Can I break in a second?
Yeah, sure, go ahead.
Well, I don't want to interrupt because I know you're in the thick of it, but the thing is, like, if you just hook the receiver up to an antenna, the antenna noise will be reflected in the filter shape. So no signal at all. You could use a white noise kind of signal, but no signal at all. You'll pick up random noise, and on your photo you should see a rectangle of the shape of the filter. And as you make adjustments, you can sort of change and peak and move all around. And also, you do not need a direct connection because, these receivers are pretty sensitive. So you just get an alligator clip and get it close to like the detector or clip it on a capacitor that's on the last IF, and you can see the response, and you can see every adjustment you make, and you don't need anything other than an SDR.
Yeah, well, the noise generator, I don't know if you ever used one of those or built one of those, Brett, but what's nice about that, it puts out wideband noise from like 0 to like 200 megahertz. So you're not depending on just ambient noise in your room and stuff like that. And you could use attenuators on that thing to give you an exact, say, like S5 random noise, and the filter shape shows up like a textbook.
Well, yeah, I don't know what you're talking about, random noise in the room. You're just talking about random antenna noise. It's probably nice to have, but you can just hook the antenna up to the receiver, and you'll see what the response is. As a matter of fact, some receivers, like the R390A, has an IF output that you can hook an SDR up and pick 455 and look at, you're looking at the IF bandwidth of it. So it's commonly done with various IFs, and you can also use the SDR as a detector, and like you can get an SDR IQ or an SDR Play and use it as on the old receivers as basically a synchronous detector and band scope kind of thing off the IF.
That's what guys are doing with those units that they buy. An HQ160 that I have, not this one, it's got an IF output right on it. But you can pick that right off of this circuit if you didn't have one. But that's the noise generators are very good with that. Elecraft, on a lot of their transceivers that they were selling, you would align the receiver when you built one of those with a noise generator. And but I just found it a more stable noise source than an antenna. Because an antenna, sometimes you're getting static crashes, it's kind of, this is like completely isolated right on the bench. And you could attenuate it. You can get it down to like an S1 or S2, to do that IF at a low input to the antenna jack and stuff like that. It works really good. But I'll tell you, the SDRs, like Brett, you reminded me of that when you mentioned that earlier, but is a tremendous tool in SDR other than just to talk on. W2SDR.
Yeah, in the old days, remember a wobulator? Did you ever hear of that?
Oh, sure.
Try finding one of them these days.
Yeah, there you go. Well, anyway, it's all interesting, but most times, they start out like you, Perry, is pretty much, your knowledge base is really advanced with transmitters and stuff, but receivers is a whole other issue. It's a more complicated issue, and you'll notice by hams that you talk to, a lot of people homebrew amplifiers, transmitters. Homebrew a receiver, you start doing that, and then you got your work cut out for you.
Yeah, it's a whole different ballgame. I'm finding that out, excuse me. But it's all fun, I just trying to get my knowledge up, just trying to get my learn on W3MMR.
But that SDR you got there is a very valuable tool, like Brett was saying.
Yeah, this is one rig I'm never going to get rid of. This is staying, unless I upgrade to 7000 or something like that, but this thing ain't going nowhere.
How many times have we all had radios that we said that we'll never get rid of, and we've gotten rid of?
Well, you haven't got rid of that 101 crazy enough.
That's because I probably forgot I had it. Years ago on some of the stuff that I've been through, believe you me, I would have sold it if I would have remembered that I had it. You know where I'm coming from.
Yeah, I'm picking up what you're throwing down.
Not for nothing. When you were telling me earlier about that tire that blew out, I remember a friend of mine, a guy that, when I lived in North Carolina for a while, was a black guy. And back in those days, cars would backfire periodically. And he had a backfire on his Chevy pickup truck. It was so loud it blew the damn muffler out of the thing. And he said, that scared me so bad I was whiter than you.
I remember when my truck was real loud? That's what happened with my truck. My truck backfired and blew the muffler up.
Yeah, I'm telling you. That's another thing you don't see too much today is cars backfiring. But back in the day, you heard it. People think it might have been a gun went off and stuff. But cars today, you don't see them backfire too much. I guess that's because of advanced timing or whatever.
Well, what happened with mine, the mass airflow sensor was taking a crap, and it loaded up, and the air-fuel mixture got off, was off, and it loaded up. It was too much fuel, and I was going up a hill, I was coming up Route 1 out of Upper Darby, coming into Springfield, and I was just cresting to the top of the hill, man. She was chugging up there. She didn't want to get to the top of the hill, and all of a sudden it was bang. And I looked in the rearview mirror, smoke everywhere, and then all of a sudden my truck went from being quiet to being very loud.
I'll tell you, some of the cars I've had over the years. I can't believe I'm still here at 68, to be honest with you. So, what else is going on, you guys? Brett and guys have big signals. Band conditions are great. Very quiet here.
I just jumped in on the Flex 5000 barefoot. I expect to get the dinner call, but I heard you guys talking, and I thought I'd just throw in my 2 cents. And by the way, before I would start poking in and anon into vintage old radios very much, I'd go out and get an SDR play, for $100 and start sticking that into high voltage circuits.
Yeah, well, what you want to do with something like that is make sure you have attenuator and at least a .01 capacitor. You got to have that before to keep the DC out of the radio. That's the major thing, is a coupling cap. You got to have a coupling cap.
Yeah, I don't think I'd go near it. Not with something that expensive. No, not when there's a dongle or something. You do pretty good with that. All right, dinner crew. See you later.
Now, Brett, wait a second. Use a gimmick. You know what a gimmick is?
Yes.
There you go. What a gimmick is, Perry, is something in proximity to the circuit you want to measure. And I've seen this in vintage CB radios, especially, where they well, you've seen it in the neutralization circuit in your DX100. The wire doesn't have to be connected to anything, it just has to be in proximity. That's called a gimmick.
No, I got you. Yeah, I put that neutralization circuit in there to stop it from oscillating when I would unkey. I also read that when doing an alignment, don't you want to couple it as light as you can so it doesn't affect the alignment?
Well, yeah, you don't want it to load down the circuit. Okay, but any high impedance, like a meter, like when you're measuring off a detector, you want a vacuum tube voltmeter, VTVM, what they call. But a modern digital is okay because it's very high impedance and it won't load down the circuit.
Okay, I got you. 10-4, good buddy. That's all fun. It's good to know, good stuff to know. Yeah, the band's been in really good shape. You're like 50 over the whole time here.
Yeah, you're about a 9 or so on the 140. I cut the sensitivity down. Now, the sensitivity on this receiver is very linear from top to bottom. So I know there's an issue with that 160. I'm going to have to track it down.
Yeah, I'm sure you'll get it. Yeah, if I have the sensitivity up on my 140 all the way, everybody has the meter pegged.
Well, the meter drifts around a little bit. It's tough to do that between the 0 and the sensitivity. Like right now, the noise. It's a very hot receiver. I mean, it has a lot of sensitivity. So it's, like when nobody's in here, it's like half scale, which is like a 5, which is weird.
Oh, that's well, mine's just sitting there receiving. Mine sits on about a 5.
Yeah. Now, if I turn the sensitivity all the way down, okay, it reads a 4. It's the same thing as when I have the transmitter keyed.
I got you. I think mine will go down to all the way down to a 0. I don't remember. I'd have to look. Today I had the muting wire because I have the 140. Everything's hooked up. It's plugged in. I have a coax for going to that and going to the 303, and I have them on an antenna switch and stuff. But I disconnected the muting wires off of the TR relay and didn't disconnect them off the back of the radio, and I started moving stuff around. I was started hearing something arcing, and it was the damn muting wire arcing against the pickup I built for my scope off the back of the DX100.
Well, it's high voltage on there, B+, but it's current limited. So it's not going to blow anything up. It's going to spark. It'll knock you across the room a little bit, but it won't kill you. But, yeah, it's... I get used to the pop. Like, I'm used to, listening to this pop now, so... And, the carrier level obviously doesn't have a light in there. I'm surprised that it hasn't bugged the hell out of you.
No. Not at all. It's just, Game 7 of the World Series is tonight.
Oh, yeah, I might have to watch a little bit of that. Well, your audio coming through this thing now, it sounds exactly like you do in person. No more bass, no more treble, no more. It just sounds like your voice. Exactly.
Well, that's what I was going for. That's a good thing. Let me see. Yeah, 8. What time does it start? 8:08 p.m. I really think that the Astros. Who's pitching tonight? I wonder who's pitching tonight. That's what I want to know. That's probably going to determine who's going to win. Who's pitching Game 7? Scherzer might be pitching tonight. Kurt Suzuki, their number one catcher, is not in the lineup. Hold on, I just missed it. Damn it. Who is it? Zach. I think it's going to be Zach Greinke and Max Scherzer. Oh man, two of the best pitchers in Major League Baseball going at it tonight.
I'm going to take a video. I turned the camera on, so you're going to give me a little bit of audio. This is just from my camera aimed towards the 140. W3MMR, W2SDR.
Yeah, W2SDR, W3MMR. Yeah, Max Scherzer is pitching tonight. He was hurt the other day. And he has Scherzer has a 2.16 ERA. So far this postseason, while Greinke has a 5.30 ERA, but in the regular season, Greinke had a better ERA than Scherzer, down in the low 2s. So we'll see. It should be a good one tonight. W2SDR, W3MMR.
All right, I'll message you this video over so that you hear what it sounds like right from the 140, just with the phone. It's amazing how good the phone does. I mean, really, for the recordings. Let's see, Perry Mayer. Let me see. What do I do here? Okay, send. There it goes, sending. I want the Nationals to win. You know why? Because they're in a division with the Phillies. I mean, they're representative of our division.
I don't care. It doesn't matter to me. I don't want them to win. I want the Astros to win. I hate Nationals. Just like I hate the Pittsburgh Penguins. The Nationals are probably my least favorite team in Major League Baseball. I just don't like them. You know? They're not likable to me. I look at them and they piss me off.
You know where I got this receiver from? No Street.
Really?
Yeah, probably 25 years ago or something. I traded him a Sonar amplifier, I think, a linear that they made for this thing, and he traded it. I mean, he didn't use it really, and I had it ever since. Yeah, back before, I don't know, probably maybe the early 90s, something like that. No, it was after that. It was after, I'm trying to think. It was after I moved here, I think. After we moved, because I don't remember having it or using it in Upland. So it was probably around 2000.
Oh, yeah, it was right after I moved there. I don't know. I always remember seeing it sitting in the basement. I just always remember you having it, so I never thought, I just figured you always had it. But I like your knobs better on yours. They're darker than mine. Mine are like a lighter chocolate color.
Yeah, I don't know. I like yours too. Yours are so clean. I guess they made two different kinds. I saw a couple of hits on the color of the knobs. I don't really get into all that minutia. But I like it because it has the hood that opens up on the top. It's pretty cool, you know, like they should have one of them things. It's like one of those, like a rod that comes up to hold it up like in a car.
I know, like a hood prop, you know? That'd be cool. Yeah, my 303's got the same thing, you know, a little lid. The 303 it runs warmer than the 140 does. I did notice that. My 140 runs pretty cool. Yeah, I'm surprised it cleaned up as good as it did. When I first went to see it, I was like, man, this thing's in rough shape. But then I looked at it a little closer and noticed there wasn't any, you know, the paint wasn't worn off behind the knobs or anything, or, you know, it wasn't worn through. So I knew with a little TLC it would clean up real well, and that cigarette tar kind of preserve things.
Oh yeah, that does it. It does preserve it. It covers it up, you know, keeps the elements off of it. All right, man, I'm going to sign, I guess, go up there, see what's going on with the cats. And, yeah, check out that video. Well, you sound real good, man. I mean, that's exactly how you sound, like, to me, sitting here. Because I think the iPhone records it pretty good, like, right from the mic, you know? So it's not like direct hookup or anything. I mean, it's just like it's coming out of the speaker. So you're hearing it as it's coming out of the speaker. And, sounds good. This has a different, you've noticed that you had enough radios now. Every radio receiver has got its own signature to the way it sounds. You know, like, other than just, does it have good bass or not? Over and above that, it's got a signature type of sound.
No, I agree. I definitely agree. And, it's just crazy to me how, with that 303, how similar it sounds to this SDR. I'm blown away with how good that receiver sounds and how old it is. Yeah, I'm assigned too. I gotta make a phone call here and call my mother back and put the leftover pizza away and relax. So, good talking to you. It was fun tonight. I'll catch up with you later. I'll check out this video. W2SDR, W3MMR.
Well, I think you'll be happy with it. You know. All right, I'll catch you later. Gonna watch a little TV, I guess. Up there, another night on YAM here, and you're getting a wealth of information from Timmy too, in the mornings and stuff. And it's a good QSO this morning. I was listening to it while I was getting ready for work. So I'll catch you later. W3MMR. W2SDR, closing down. See, I'm going to set the timer on my phone now for like 20 minutes. So I'm going to give this amp and everything a chance to cool down before I actually shut it off. W2SDR, 7-3.
Good night, everybody.
Oh, good night there, Clark.
Yeah, all right, Clark, I'll see you. Yeah, I always wait to shut my stuff down. I sign off and then I leave it on for a while. Probably like an hour or two before I go to bed. And then I'll come in here and shut everything off. We'll catch you later, Clark. W3MMR.